Okay, Battery Tech 2. This is going to be all about different lead acid technologies. You really should listen to all of this if you are an off-gridder or an RV-er. Now, there's three different ones you're liable to see from day-to-day use. Car batteries, marine batteries, and deep cycle batteries. What they basically do with car batteries is I don't know if they put bubbles through them as they're melting the lead or what, but they sort of make them so they're effectively spongy, the plates. And the purpose of this is to create a larger surface area. Deep cycle is the exact opposite. They are not spongy at all. The idea of this is to not have as big a surface area. Now what that means is your deep cycle, you can't draw a massive amount of amps, but you can discharge them quite a lot. Whereas your car, you can draw a massive amount of amps for cranking over a cold engine, but you can't flatten them very much. And marine is a sort of hybrid between the two. And yeah, quite simply, you'll see things like CCA on car batteries. That stands for cold cranking amps. That's the amount of amps you can draw in a big hurry. And deep cycle, you'll see AH, capital A, little h. That means amp hours. Marine may have both, and you may see some other different ones, but I sort of don't really take much notice of the other markings. But what we're going to be looking at is deep cycle. So what sort of different deep cycles are there? Well, everybody seems to go for one called sealed, and I don't really recommend that. I'll explain why later. But you've got wet type, sealed, and you'll hear other names come up like AGM, which stands for absorbed glass mat. When you see SLA, that just means sealed lead acid. That's just sealed. And you'll see VRLA, which means valve release lead acid, and gel cell. And yeah, where to start? We'll go through some of these names. Wet type is just your ones with your caps on it, and the stuff, you know, the sulfuric acid is literally just sloshing around wet. They're very basic. They are also very hardy. They are also very, because of the fact they've got caps and the simplicity of them, you can sort of do things to revive them and make them have a lot longer life than you do with your sealed ones, your gel cell, and stuff like that, which is why I go for wet type. They can handle a lot more pushing and shoving and harder, heavier voltages and stuff than all the other ones can too. Now sealed just means literally, it's sort of the same, but it's just, there's no caps on it, so to speak. Now AGM is absorbed glass mat. And what that means is you got matting, which is basically like, not the fiberglass insulation on your roof. It's more like if you've done fiberglassing boats and stuff like that. That sort of matting that you use with fiberglassing, it's like that inside your battery, acting as a sponge, and the acid is kept from dribbling away if the battery's turned upside down or whatever, or not much will get away because it's sort of soaked into this glass mat like a sponge. That's the idea behind that. The VRLA, valve release lead acid, you know, conjures up ideas of little car valves with springs on them, and what they basically are supposed to, that's not how it is, but what they're supposed to do is when you get your bubbles, your hydrogen and oxygen bubbles that come off during charging, or you get a lot of them as the battery's getting old and starting to die, what that does is your VRLA allows those bubbles to be released. Now, it's a bit of a furphy calling it valve released lead acid, because you think of this little valve like out of a car engine. Nah, that's a lie. What they do is they have the cell as usual, and when it comes to the top, it goes like into a little circle, and it sort of necks up a bit. And on that neck, they stick a little rubber cap, and it neatly fits over the top. And all that happens is when those bubbles build up enough pressure, they force their way past the little rubber cap that's gripping onto this little neck. So that's your valve. It's your shonky Chinese version of valve. But, you know, it does the job. I've been told that in these sealed lead-acid batteries there's supposed to be something that tries and gets the hydrogen and oxygen to turn back into water and re-enter the rest of the acid in the battery. I do not know anything about that. I've not seen any strange things which do that, but I don't go putting hammers through the side of sealed batteries on a regular basis. Having said that, Battery Tech 3 will show the insides of one out of my old hot water system. Well, the hot water system I'm still using, but the battery's a dead horse. Now, so I cover the gel cell. They are really good for getting a good shaker, because they literally don't have any liquid sulfuric acid in there. They put it in like this gel crap, and it's just like, you know, some sort of goopy stuff that's acidic, and they literally just have all this gel in between the plates. Now I'll get onto the big kicker, the difference between these wet types and sealed. Sealed can't take too much volts when it's charged. It's, according to my charge controller book on my solar fridge, it's 14.3 volts, and the wet type is 14.8. Your average run-of-the-mill car is 14.4, and yeah, so they can't take as much of a voltage. Now, I've had a bit of a trouble using a charger built for a wet type on a sealed battery with me hot water system battery, which is why I'm slowly murdering it. And I think once we're into winter, like almost to spring, I think she might be about dead. I can feel it's dying now. Might even get to winter. So yeah, you've got to sort of realise that they take different voltage charge rates, and why this one I've got here for the wet type batteries is burning out the sealed battery is because the sealed battery doesn't want to reach 14.8, although the battery charger will only cut off when it does reach that. So in the process, I've heard a couple of bubbles occurring, and it's also making the charger very hot and not doing the battery any good. Occasionally, you know, it'll go off. It was switching to green and going to trickle charge quite a lot of the time originally, but it's not doing it as much now. So I've got to sort of literally just wait 2.5 hours and charge it for 2.5 hours and go and touch it to see if it's getting hot, and, you know, estimate what I'm going to do. If I'm going to turn it off or let it go for a bit longer. Yeah, stratification and equalisation. Your cells, because you got like 6 or 8 cells per deep cycle battery, my little 6-volt one's only got 3 cells in them. You have, like, those cells are supposed to be all the same voltage. Some of them get out of whack from the rest, and they'll be different you know, each cell might be, the voltages will be different with some of them. And what you do is you basically pump in about 15.5 volts for anything from 2 hours to 12 hours with this equalised charge. Only ever do this with wet type. If you've got it automatic, like the solar fridge one has got a switch, and it'll do it automatically for 2 hours every month. But I've turned that off. and it come with it turned off. You've got to be sort of, you can only do it with your wet type. And what it does is, these cells all being different volts, it equalises them and it makes them all the same volts by forcing in not 14.8 but 15.5 volts, causing it to bubble, but all the cells go back to an equal amount of voltage. In the process, it also blasts crystals, it blows out crystals of sulfur that are stuck on the plates. It blows them out of the pores and off of the plates and all that, so that you have a higher battery capacity. And stratification is where, especially this is more the case with off-grid houses where the batteries don't move, the acid will be more acidic in the bottom of the battery and less acidic at the top of the battery. And it's like the acid sort of sinks effectively, and it goes more sort of watery, less acidic at the top than at the bottom, and it'll eat out the bottom of the plates. Now when you do this equalised charge, because it's boiling, it stirs it all up again, and then it's sort of, and they call it stratification because it's sort of this bit where it's sort of, the acid sinks to the bottom of the battery. When that stratification, when it sinks to the bottom, but you fix all that with the equalised charge because it starts bubbling and it stirs it all up again. But don't do that to sealed, and don't do it to gel cell. The gel cell, really don't do it. It might survive it once or twice with a sealed, but it will not survive it with a gel cell, because after a few hours of equalised charging, what happens with the gel cell is the bubbles create between the gel and the plate, and then that's it. That whole area is just dead, because the acid is no longer touching the plate, and you get that on all the plates, and that's it. The battery is just a bin job. But yeah,